All right, hello, grade nines. Today we're going to talk about 4.6, which is all about how to model and analyze the data that we've collected. So it's the last step in the statistical modeling process, where we've already thought about what we want to collect, what data we want to collect so that we can answer what questions. We've talked about who, what, or where was part of our population. We've also talked about how to design kind of our data collection. So we talked about experiments and manipulated variables. We've talked about observations. We've talked about surveys and how to ask good questions. And we've talked about samples and how to ask only a partial part of the population, or how to collect data from only part of the population versus a census, and when to do what, and etc. This last step, step 3, assumes we've already done all of that. We've collected the data, and so we have a whole bunch of results sitting in front of us, and now we want to organize it, put it into some sort of model, and then we want to analyze it. So we want to look at that data and then make decisions, or take a look and observe and see what that data is telling us. So when we model the data, once the data is collected, the next step is to organize it. Data is often organized graphically. So picture form in some sort of type of graph. As visual representations often make it easier to notice patterns or trends, but also can be used to share with other significant parties. So a pattern is something that is happening repeatedly. So I might notice that my data goes up and then back down, and then back up and then back down, and then back up and then back down. That would be a pattern. A trend is kind of like an overall representation of that data that is changing in a consistent way over time. So it's not fluctuating where it's going down and up and down and up and down and up. But I'm looking at the big picture changes. So a trend might be, if I squint my eyes a little bit, I'm not seeing the day-to-day changes of something, but I can see that overall it's going up. So let's picture, like, really quickly, the stock market. Now, you might not know what the stock market is, but the stock market is essentially, if I'm taking a look at every single business, let's break it down. Instead of just the business, let's look at one business at a time. I want to see the value that business has over the long period. Now, let's imagine we have a startup business. We decide to sell, math guides or math notes, or, a tutoring service for grade 9 math students. And we're just starting this company. I want to know the value or worth of that company in dollars over time. Now, when we first start, we are making $0, because when you start anything, you're starting from square one. You likely do not have any money coming in. Now, over time, I'm going to see that value kind of go up, right? But it might go up and down and up and down, and like have a little bit of this kind of thing. There'll be some busier months, there'll be some, slower months. But as I go and I develop my business, it is overall potentially, or in this case, how I'm drawing it, increasing in value. There are some days that I'm like, whoa, that really took a plummet. And there's some days where I'm like, wow, that really spiked up. I got a lot of customers today. Got a lot of people to purchase my product. Now, when I talk about a trend, I am not looking at the day-to-day ups and downs. I am looking that if I am just drawing like a single line to match it, or a line of best fit, or a curve of best fit, right? I'm trying to match that data in like a big picture way. So I'm kind of squinting and I'm thinking, what do I see if I stand really far away? I kind of see this line. And this line indicates that it's going up, right? It has a positive slope. It's going up. It's increasing. So a trend doesn't look at the specifics. A trend looks at the big picture. And a trend in this case is that the value of my company is increasing over time. So the value, is going up as time goes on. That's what a trend is. And we'll talk a little bit more about what trends are later on. But just so that we have an idea that we're not writing down a word and then kind of figuring out what it is later, but having a sense of what that means right at the beginning. Okay, so when we collect data, depending on what our data is, sometimes there's different ways to represent it because there's more than one way to represent a graph. So we're going to be talking about different graph types, and then we're also going to be talking about when that type of graph should be used, because it's not always best used for every type of data. Some graphs have advantages over others. So let's talk about a line graph. A line graph uses points that are points connected by lines. So as simple as that. So we'll plot points, and then we'll take all those points, and then we will connect it with a line. What that does is it shows changes over time, or the relationship between two variables. Okay? So on the right here, we have a graph, and I take a look at what that graph says, or what it indicates. It looks like I have Winnipeg's temperatures measured in degrees Celsius. I have months along the bottom there, right? So I can see I have January, February, March, all the way to December. And then I have the numeric data. So really what I'm doing is I'm looking at the temperature over time. So how the temperature changes over time. Or I can also say I'm looking at the relationship between temperature and the month or time of year. So this is what the line graph here does. Now this graph isn't the most ideal for a couple of reasons. I can see there's a red curve and there's a blue curve, but it doesn't tell me what those curves represent. And now if you look at this, think of what those red and blue curves might possibly represent. What do you think they could? Share that idea with the person sitting at your table. Okay, I know this graph is poorly labeled in the sense that there is no legend. It doesn't tell me what those lines represent. But the red actually represents the high of temperature for each of those months. And the blue represents the temperature low for each of those months. Okay, so if I look at the weather app every morning, it'll give me a high temperature and a low temperature. That's what these two represent. So what they've done in this line graph is they've plotted the points. So if I'm looking at May, here's May, right? And they've plotted the high May temperature and the low May temperature. Again, the graph isn't great because it also doesn't tell me the year that I'm talking about it. But the high May temperature might be around 17 and a half, 18. The low May temperature might be around 4 degrees Celsius. And so they're plotting the points, and they're doing that for every single month. So that's what these dots represent. Those are your plotted points. And then they are connecting them with a line. In this case, that's a little bit more of a curve because that's what my data requires. It's not just going up. Okay, so that's a line graph. It is best used for showing trends or changes specifically over time. So tracking temperature over a week, showing the changes in stock prices. What else? Showing like math equations, how one variable y changes when I change another variable x. When I want to show someone's height versus their shoe size. Okay, if I want to show their height versus their age, how their height is changing over time. So if I'm looking at two variables at once, line graphs are pretty good. Okay, the next is a bar graph. A bar graph uses rectangular bars to represent data. The length of each bar corresponds to the value of the category it represents. So if I'm looking here, here's my bar graph. There's a line drawn in, but I don't really need to kind of focus on that right now. I'm looking at all those rectangles. This rectangle is not coming up super well, but here I go. So there's 5 different categories, A, B, C, D, and F. There's no category E here. And it says that represents my score ranges. So if I'm wondering why there's no E, think about like letter grades. Get an A plus, B plus, C, D. There is no E in terms of score, and there's F. And then on this side, it says number of students. So this side, the lowest setting would be if I had 3 students. Here would be 0 students, then 3, then 6, then 9. And it's going up by a consistent amount. It has a consistent scale. So I'm not going up by 3, then going up by 7, then going up by 2. Okay. This graph is a little bit better than the one above because it does tell me some information about the data. It's telling me that the categories are grades in like letter grades. And this talks about number of students. But it's still not an ideal or perfect graph because there's no title. What are these grades for? Is it a university course? Is it like grade 3 in reading level? Like, I don't know what this data is for. So it's not a lovely, perfect graph. It's not my favorite, but this is what I've got. Okay. Now, the height of the bars tells me how many students. So, like, there'd be 9 students who got an A. There'd be likely 10 students. That's not a straight line. But there'd be likely 10 students who got a B. It looks like 15 students got a C. And 6 students got a D. And again, it looks like 9 students got an F. Okay, so I can use the height of each rectangular bar to tell me about how many people or items belong into each category. Okay, when we take a look at bar graphs are really good for comparing different categories or groups to each other. And so here we have groups of students who received each letter grade. I can talk about special events. They had a junior dance and they were tracking how many people bought items from their canteen. So how many root beers, how many Pepsis, how many Sprites, etc. And we took a tally of all of those sales. We can represent all of those sales in a bar graph. I could put at the bottom Pepsi, Diet Pepsi, root beer, 7-Up. I think we actually sold Sprite. So Sprite and Orange Crush and Cream Soda and Grape Crush. And then we can make a bar chart that represents all of them. The number of sales would go on the vertical axis, the axis that goes up and down. And the types of pop would go along the horizontal or the left-right axis. Okay? So it's really good for comparing categories or groups. All right, next we have circle graphs. Sometimes circle graphs are called pie charts, right? Because you're looking at those and it kind of looks like slices of pie that you get. A circle graph is divided into slices to show how a whole is divided into parts. So this would be good if I'm taking a look at some whole categories. So if I wanted to know, let's say, your opinions on what your favorite pop is, that was the last thing in my head. And I said, okay, how many of you out of, everyone in the class would prefer Pepsi as your number 1 pop? How many of you would prefer Diet Pepsi? How many root beer? How many Sprite? How many Orange Crush? How many iced tea? How many Purple Crush? How many cream soda? And again, I might only have a limited amount of options because maybe those are only the options that I have at the dance for sale. And I said, what would be your number one preference out of the items listed? And you'd be like, oh, I like iced tea. And someone else would be like, oh, I like cream soda. And someone else would be like, oh, I like Pepsi. Okay. And I could put all of those into a circle graph because I'm taking a look at the whole. Okay. So everyone that I've collected data from, in this case, everyone in your class. And then I'm dividing you up into parts based on your preferences. So when I look at a circle graph, every slice, or if I'm looking at a pie chart, sometimes it's called a pie chart because you're like, it's a slice of pie, represents the category with the size proportional to its value. So if I have a big value, I'm going to have a big slice. If I have a small value, I'm going to have a small slice. So taking a look at this is an example, favorite ice cream flavors, and it shows here are the 4 options or the 4 that were selected, and then here are my results. Now, this graph is decent because there is a legend, so I automatically know what the blue slice and the red slice and the green slice and the orange slice all represent. And just by looking at this, I don't really need to see the percentages to know which one is a crowd favorite. I know that chocolate has the most amount of people who like this ice cream flavor. The one thing I don't really like about this graph is it only tells me the percentage of each category, but it doesn't tell me the number of people. So I don't actually know how many people they've surveyed for this particular data. But if there was 100 people, it would be good to know, okay, that's 35 people, 40 people, 18 people, 7 people to make my total of 100. But if there was 200 people, then I'd like to know, okay, there's 70 people in this category and 80 people in this category and 36 in this category and 14 in that category. And why that might be helpful is it also then tells me, like, okay, if I'm having an ice cream party for all of these people here that were selected, I know I need to buy 70 servings of vanilla, right? So that can be a helpful bit of information. Also, we know that for samples, we have to survey at least 10% of the population. I also might want to look at this as if I get really, really small numbers, like you've only surveyed, let's say, 20 people, it could still work out to 35 and 7 and 18 and 40%, etc. But I might look at those numbers and go, wow, that's a really small sample size. That might not be enough for me to say that that data is reliable. So that would be the one thing I would say kind of missing. As favorite ice cream flavors of who? Is it of seniors? Is it of students? Is it of toddlers? Like, tell me more of who this pertains to. So not a great graph, but still decent. Now, circle graphs are best used to show proportions or percentages of a whole. So if I'm looking at a large group, I want to know how that large group is split up and what their preferences are. So I might use this for, showing the type of transportation used by a group of people. How do you get to school? And I survey every single student in the school. I do a census and I go, okay, this percentage of students bike, this percentage of students drive, this percent of students walk, this percent of students take the bus, this percent of students do something else, so like a rollerblade or skateboard or whatever. And I might go, oh, hey, look, 20% of students walk. I really want to make sure that I'm putting money into plowing the sidewalks right when it snows so that I could accommodate those students, right? Or if 99% of the students drove, then maybe I want to consider getting additional parking spots or, widening the lanes so that I have 3 lanes across instead of 2. So that can be another way or another example of when I would use a circle graph. The last type of graph is a pictogram or an infographic. Pictograms use pictures or symbols to represent data, often with each symbol representing a certain number of units. So let's just zoom into this example. This is a pictogram. Now in a pictogram, I have some symbol here or some picture, and I'm trying to answer though, even though most people believe goal setting is important, only 2 in 10 people say their life lacks an overall goal. So 2 in 10 people, I can see there's 10 people drawn here, and it says 2 in 10 people, so only 2 people are colored in a different way. When we take a look at this, I can very clearly see that I've got 2 out of 10. Without even reading, without even looking at anything, all I need to know is be able to count and go, okay, there's 2 different out of 10 that are going on here. Now, pictograms are best used to represent data in a visually engaging way that is easy to understand at a glance. I would say that often if we're showing like data to the population and I want the majority of the population to understand what's going on, so people that are very young, people that are very old, people with language barriers, people who maybe don't have a lot of education, people that maybe have education but don't totally feel confident interpreting graphs. Pictograms are really good to be visually engaging and to allow people from all walks of life to understand kind of what's going on here. And so I think that if I showed this to a 3-year-old, they would be able to tell me, oh, there's more pink people than yellow people. And like a 3-year-old doesn't understand the context because they can't read everything, but they can still understand a little bit of what's going on. And if you show this to a 3-year-old, like those pictures of what they're thinking, they might go, well, 8 people don't know because 8 people have thoughts that are questions. And 2 people might know because 2 people have those thought bubbles with things inside of them, right? So a pictogram is really there to appeal to the masses and to be visually engaging. All right, another way that we can use this as an example is show how many people own different types of pets. So I could have pictures of animals. So I can have like 3 dogs and 4 cats and 1 bird, and then on like all next to a person. And then I could show 7 people without an animal next to them. And that could be one way to represent the types of animals people own, right? The people alone would show people without pets. The people with dogs would hopefully show people with dogs. The people with cats would show people with cats, etc. So just a visual way for us to represent that data. Now, once we've modeled that data, and when we go into Excel, which is 4.7, we're going to learn about this, we're going to be talking about how to actually build these types of graphs, specifically bar charts or bar graphs and circle graphs. Those ones are going to be the most common for our purposes. So we're going to learn how to graph those. But once we take a look at a graph, regardless of what graph we have, we should be able to analyze and look for patterns or trends or just straight up differences in the data. So here are some examples of what we can do to help analyze the data. First and foremost, we could look for trends. These are patterns that exist over time. This can be including data that is increasing, so it's overall getting bigger or going up. We can look for data that is decreasing, so the opposite. It is going down over time. Or a trend could just be that it's staying the same. Right? We might not notice any change overall, which could also be a trend. Aside from identifying trends, we can also compare categories. So in like a circle chart or a circle graph or a bar graph, I can use these or even a pictogram where I'm looking at the categories to see which has the highest or the lowest value. So I can go for my bar chart example. My highest value is the most amount of people scored a C on this assessment or on this course. And the fewest amount of people scored a D, right? So there's not really necessarily a trend to follow here, but I could look for highest and lowest values. For graphs, I can look also for outliers. So in any type of graph, if there is a data piece that is like way out of proportion, it's much higher or much lower than I expected. So notice any values that are much higher or much lower than the rest of the data, that might stand out. So when we take a look at the graph above, specifically for weather, I don't really have any outliers here because look at my pattern. I'm going up and I'm going down. But if one year I tracked in July that my low temperature was -15 and my high temperature stayed the same, and I'm looking at this bottom one, drawing the smooth thing, and then suddenly I'm divoting and going up, well, that doesn't look like a really good pattern. That would be an outlier in the data, right? Something that is much lower than we expected. Okay, so I can talk about outliers as a way to analyze that data. And last but not least, I could understand proportions. So specifically in circle graphs, I could see how much each part contributes to the whole. So kind of looking for the highest or lowest, but kind of looking for the biggest or the smallest slice. Just a different way to talk about categories. Okay, so I'm looking for the biggest slice, which contributes the most, or the smallest slice that contributes the least. Now, taking a look at these data pieces, specifically trends, but patterns, trends, and differences, once we've noted all of those, we can use those results to make predictions going forward. So, what do I mean by predictions? Well, let's go back and look at some examples really quick. If I'm looking at this graph and I'm going, okay, 9 people scored an A, about 10 scored a B, 15 a C, 6 a D, 9 an F, I could make predictions. Now, I'm not making predictions about certain numbers, but in this case, I know the most amount of people scored a C and the least amount of people scored a D. If this same class wrote another assessment, so maybe this was their results of their first quiz, and I wanted to predict how they were going to do on a second quiz, I might also predict to have the results be somewhat similar. I might still predict that the most amount of students are going to score a C and the least amount of students are going to score a D, right? So I can make predictions about future assessments. If I'm taking a look at temperature and going, okay, I plotted all this data and the year was 2021, and I wanted to predict which month would be the hottest month of the year, I might look at this data and go, okay, next year, I don't know for sure because it hasn't happened yet, but I would predict July is going to be the hottest month based on the data I've seen. Okay, so I could make that prediction going forward. Or I can say what would be the coldest month, and I could go, oh, January has the lowest plotted points. I imagine January is going to be the coldest month, right? Or if I just took a sample of students in grade 9 and surveyed their ice cream flavors, and then instead wanted to be like, okay, what do all grade 9s everywhere enjoy out of these 4 possible options? I might make the prediction that the most amount of grade 9s are going to like chocolate ice cream. And the second most popular flavor is going to be vanilla. So I can make predictions based on the data so that I can go forward and make decisions with those predictions. Okay, that's it. That's all. There's practice that follows. Please take a look and tackle that. Also, please look at the peak of the week because starting tomorrow, we are going to be in the library to work on some Excel stuff. We're going to be at the computer lab. And the location's not always the same. Sometimes it will be, sometimes it won't. But please look at the peak of the week to know where to meet for attendance. Okay? All right, have a great day. Talk to you tomorrow. Bye.